Alright, in this video I'm going to show you how to perform complex number calculations in your Casio calculator. I have a couple of examples here that we're going to be using, and I'll just go right into it. So first of all, I'll just clear things out, and just so you know, the mode here is the major thing we're going to be using. So to perform complex number calculations, we have to set our calculator to complex mode, which is the mode 0. So I'll simply click on the mode here and select 2. As you can see, the complex is showing here. Just so you know, it is preferable you leave your calculator in the math mode when doing most of these calculations where you do complex numbers and so on and so forth. As the case might be, you might get your values in or your answers in fractions, but you can easily toggle it. Here I wrote out this example: 2 plus j6 plus 3 plus j2, and that is the basic way to represent J notation in your engineering format. But with the calculator, we are going to be displaying it this way. So instead of 2 plus j6, we'll be using 2 plus 6i, and then this other one is 3 plus 2i. So the complex number here is represented with I, as against what we have in electrical engineering, that is basically j. So since we are in the complex mode, all we have to do is just type in this all we have to do is to type in these figures just the way they are. So to do that, I will press my bracket and I'll do 2 plus. Now, like I said earlier, we represent it this way using the calculator. So I'll do 6, and I introduce my complex number here. So you can see it here. So if I close this, we have introduced it. So I close the bracket plus the second part of the equation here is 3 plus 2i. I close brackets. Just so you know, if we are not in the complex mode, you should know, of course, that this will not be responding. It's only respond because we are already in complex mode. So once we've done this, we can just press that equal to sign, and we can see that our answer has been given unto us. You can see here it simply added the real values and then added what the imaginary number. So we have 2 plus 3, which is a real number, and then the imaginary one is 6 plus 2, which is 8. Basically, performing additions and subtractions in J notations are straightforward. When it comes to multiplication and division, that is where we have some little complications. So now let's use this example here to move further. So I'll do one more before this. I'll just do this same equation we have here, but instead of addition, we'll do multiplication. So I can actually take this back here, and instead of addition, I'll clean this out and I'll put multiplication. So if I press my equal to, it actually performed that complex multiplication, which requires us to open up this bracket. 2 times 3, 6, 2 times this, we have 4i plus this times this will give you that is 18i. Then 6 times 2 is 12, and then when you multiply I by I, it gives you -1, and after all that, you're going to have the final result to be this. So now also, if you want to perform this other example here, we just clean this out. We do 2 plus 6i divided by 2i. Okay, equal to, the final answer is 3 minus I, which is the same thing as 3 minus 1i. Okay, I think this is straightforward because we are using our calculator here, but if you're actually going to solve this on with pen and paper, we'll see how complicated this can be. So this second example here is a popular thing we see mostly when we have complex numbers, where we have to move from polar form, where we have two at an angle 45. This is the real magnitude and this is the direction, and we have to take them to J notation. So how do you go about this? Since we're already in our complex mode, you can just type this thing direct, type it in direct, and then we get the answer in J notation. Okay, so I'll just type this out 2, and now to press to get our angle, we use shift of this, then we can actually type in the angle here. So the angle here is 45. If I press equal to, it's going to give us the corresponding J notation for this particular answer here. And then I will just do one more calculation, this one more example, and then I'll see if I'm going to show you how to convert from the J notation back to the polar form using your calculator. So to do that, I'll just go back to my equation here, and that's 5 at an angle of 53. If I do the equal to, that's giving me that my answer is 3.0090 plus 3.9 something something I. But in order for it to display properly, you just press this button here, and then we can see clearly this is the real, this is the imaginary part. So it's approximately 3 plus 4i. That should be our answer. So now to take this back to J, okay, this is already in J notation. So to take it back to polar form, what you simply need to do is to use the complex number command. So I'll just press shift complex, and it had given you 3 or 4 options for which to display your answers, and then this here is a polar form and it corresponds to number 3. So if I press 3, it's asking me that do I want to display my answer in polar form, where you have the ray and then the angle. So if I click equal to, it takes me back to 5 at an angle of 53.10, which is the value we initially inputted here. So let's use this example again to go back and forth and see how it works. So 2 at an angle of 45, 2 shift angle of 45 was equal to this. Okay, so this is the answer we have now. So our answer is this. So I want to take this answer back to polar form. So how do I do? Like I said, you press shift complex and you're asked which angle, which way do you want to display it. I press 3, display it in polar form, and then boom, we are back to where we once started. That is it for this video. See you in the next one.